This is MATHguide.com, and my name is Mark Karadimos. In this video, we're going to look at the projection formula for vectors. In our first section, we're going to talk about the formula. In our second section, we'll go over an example. In our third section, we'll go over another example. And in our last section, we're going to talk about what it means graphically to have a projection of one vector on another. Okay, let's get started. So this is the formula for the projection of vector B on top of vector A. Okay, so that's how you read the left side of this equation, the projection of vector B on vector A. Okay, now the formula that we use, I've broken it up into two parts. Sometimes people mash these together, but I think it's more understandable when you look at it in this fashion. Okay, so what do? Well, I have two fractions that I'm multiplying together. Now the top of the first fraction says that I'm taking the dot product of the two vectors. Now if you don't know what that is, you're going to have to go back and watch some MATHguide videos to understand that. Okay, then we're going to take the magnitude of vector A, that's what that denominator means. Then we're going to multiply it by the unit vector of A. So what does that mean? We're going to take vector A and we're going to divide it by the magnitude of vector A. Okay, so we get this crazy concoction for our first fraction times the unit vector A. Okay, so in the next couple sections we're going to take this and use it to do a few problems. Let's take a look at our first example. All right, if we're going to find the projection of B on vector A, I'm going to use this formula. This formula has two parts. So the first part says I'm going to find the dot product between the two vectors. So that means I take 7 times 3. Then I multiply 2 times 5. You find the sum of those products. In the denominator, I've got to find the magnitude of the vector. Okay, so, and that's vector A. So vector A goes 7 to the right, and it goes 2 up. So it looks like this. 7 to the right, 2 up. Now, of course, magnitude just means what's the length of the vector. So I'm going to do a little right triangle Pythagorean theorem. So I know that the hypotenuse squared is equal to the sum of the squares of the legs. Okay, so I know that this c squared is going to be equal to 4 plus 49, which is 53. And you take the square root of both sides, you get square root of 53. All right, so there's our magnitude of A. Okay, now we're going to multiply it by vector A. Vector A is 7, 2. And our denominator again is the magnitude of A. That's square root of 53. Okay, so let's actually deal with this. So this is 21 plus 10, that's 31. I get square root of 53 times square root of 53 is 53. Now multiplying it times 7, 2. Okay, so when I multiply a fraction times a vector, that's a scalar quantity times a vector, I multiply the scalar quantity times 7 and the scalar quantity times 2. Okay, so that means I take 31, 53, 53rds that is, and multiply it by 7. I get 4.1. And then I take the fraction times 2, 1.2. And there you go. That's our projection of vector B on vector A. Here's example 2. All right, again, I'm going to look at this as two different fractions. First thing I like to do is calculate the dot product. So I take 5 times 4. I multiply -3 times 1. And of course, I've got to find the sum of those two products. All right, and now in the denominator, I've got to find the magnitude of A. So vector A goes, let's see, it goes 5 to the right, and it goes 3 down. All right, so I'm trying to find this vector. Okay. So that was 5 to the right, 3 down. Okay, so let's get that. So to get this value c, which of course we know is going to be the Pythagorean theorem, c squared is 5 squared plus 3 squared. So I know that that's 25 plus 9. If I take the square root, I get the square root of 34. Okay, so I know now that this is the square root of 34. All right, now I know that I've got vector A. Vector A is, we know, 5 minus 3. If I know vector magnitude, that is the magnitude of vector A, is square root of 34. All right, in order to deal with this, the first thing you do is multiply. You get 20 and negative 3. 20 and negative 3 is 17. If I multiply square root of 34 times square root of 34, I get 34. And of course, now I'm going to multiply it times the vector 5, negative 3. Okay, so when you do that, of course, you take the fraction times both of those values separately. So I take the fraction times 5. And by the way, 17 over 34, that's a half. So I'm really taking a half times 5, which is 2.5. I'm taking half times negative 3, which is negative 1.5. Okay, there you go. There's our answer of our projection of vector B on vector A. All right, let's talk about what it means. What does it mean if I take the projection of vector U and I project it on top of vector V? Okay, let's take a look at this graphically and understand at least what it means. So when I find the projection, what you have to do is imagine if you had a light up here and you're shining the light down on vector V. Now imagine this light, and this light source far away was coming down, and it's coming down perpendicular to vector V. So it's just shining down perpendicularly on vector V. What's going to happen is U is going to cast a shadow. Okay, it's going to cast a shadow on top of vector V. Okay, so what does the shadow look like? Well, kind of looks like that. Okay, and that's our shadow. That is what the projection is, and that's what we're trying to calculate. We're trying to find the length of that shadow vector on top of V. Okay, you think, why? Why do we need to do it? Well, that's a whole other topic, and there's related to problems in physics, and sometimes we have to get two vectors to align in the same direction to make some calculations, like for instance for work. Okay, so when you calculate work problems in the realm of physics, I have to get whatever part of vector U is in the direction of vector V. Okay, anyway, I wanted to show you what it looked like graphically, and there you have it. Okay, make sure you go to MATHguide.com, check out our other instructional videos, interactive quizzes, and text-based lessons. Take care.